Okay. All right, so what does the square root graph look like? I love how everybody's just like that. That is correct. It just looks like this. There we go. All right, let's just do domain and range just because it's here. We've already done this basically. What's the domain of a square root graph? What numbers can you not square root? Can't square root negative, so you have to be bigger than 0, right? So there's two ways to write it. We can do the x is greater than or equal to 0 XER. That's kind of the old, I don't want to say old. That's the way you've learned probably in grade 9, 10, 11. Or this year we started with the, yeah, I forget what it's called though. The notation with the brackets. So it would be 0 to infinity. Infinity is always a round bracket because that does not include the number, and infinity is not a number. But 0 is included, so that's why it's a square bracket. Infinity is not a number. It's sort of an idea, right? You just keep getting bigger and bigger and bigger. It's a concept. That's a good way to say it. But you can divide. If you take calculus, you learn how to divide by infinity. So, for example, 1 over infinity, or any constant divided by infinity, is 0. Infinity plus infinity equals infinity. Infinity minus infinity is you can't do. I don't know why I'm telling you all this. This is not even in this course. Infinity over infinity, you can't do that either. Go away. 0. What is? I need a new battery for this pen. Okay, we're getting sidetracked here. Sorry. Anyway, there's a whole bunch of stuff you can do with infinity. All right. What is the range of this function? Both are greater than or equal to 0. 0 to infinity. Okay. All right. That's just setting up domain and range, a quick little review. I want to practice transforming the graphs and just doing quick sketches of it. That's what we're going to do right now. So. This one? Oh, yeah. Sorry. Is it an E? Is that what you're asking me? Like that? Yeah, you can think of it like that. It means in the set of, actually. So what this says is Y is in the set of, and the R is actually look like this. In the set of all real numbers. But we just say YER because it's easier, basically. But that's what it means. Okay, forget all that. All right, here we go, sketching the graphs. So, y minus 4 is equal to root x plus 2. What do I need to do first? There you go. Okay, so what have I done? What has happened here? Up 4 and left 4. Yeah, so we go up 4. H is negative 2, so we went left 2. So it's left 2. Whoa. And for a graph like this, just move the center. What is going on here? I think I need a new battery here. Oh. There we go. Just move the center bit here. So left 2, up 4. There's 4. Looks like that. Good enough. I just want a quick sketch. Okay? Are we okay with that? Oops. Oh. Where's the next page? 149. There we go. All right. This is your next page, right? Okay. 2y is equal to root negative x. What do I need to do first? divide the 2. So there's 2 ways to write this. You can write it like that, or you can write it like that. I prefer the second method because you can see the a value quite clearly. So a is equal to a half, b is equal to minus 1. So what does the half do? Squishes it. What does the negative 1 do for b? Over the y-axis. So this graph should open. Oh my gosh. There we go. Open the other way and open. Oh my. Open a little lower. I did it, but I think the battery is dying in this pen. All right, next one. Move the 5 over. So what have we done? What's the negative do? Is that an A or a B? A. Yeah, so A is negative 1, so it flips it over the x, and the 5 moves it 5 units down. So it looks like that. And what about D? I want to know B, H, and A. A is 3. We can all see that. What do I have to do with this to figure out B and H? Well, we can see B, but... Yeah, so pull the 2 out of the middle there. What are you left with on the inside? X minus a half. Or x minus 0.5 for the people that prefer decimals. So A is 3, B is 2, which is a horizontal stretch by 1/2, and H is 1/2, which means you went which way? To the right. So we're going to get a vertical stretch, which opens it up. Then we're going to get a horizontal stretch by 1/2, which compresses it. And then we're going to move it 1/2 unit to the right. So I'm just going to say that's a 1/2. And it's going to look like, I don't know, that. I'm just looking for a quick sketch here. I just kind of want, this is more of a review. Is it going the other way?
It's supposed to be on the right.
Oh, it's right, not left. I was just testing to make sure you knew which way was right and left. How's it go? All right. One final question and we are done for today. Hello. Anybody know that guy?
Nope.
Yeah.
All right, this one. Tell me all the things we have done. But what do we need to do first? This is page 150.
Gotta isolate the 3 in the bracket.
Yes, you got to isolate the 3. So we take the 3 out, get an x minus 4. Okay, what's our horizontal stretch by? 1/3 or 0.3 repeating for those that like decimals. Stretching vertically by a factor of 2. That's the vertical stretch. Reflecting in the x-axis, right? This is the vertical flip. -2. Translating how many units up? And how many units horizontally? 4. No. You have to factor it out to get the B to the H. 4 units to the We're going right or left?
Right.
Right.
It's right.
Right? Because h is equal to 4. What makes the inside 0? Right. Okay. All right. 1, 2, 6, and 7. Tomorrow, like I said at the beginning of class,